Hello girls, hello boys. So let's today we will solve the problem. It's called a distinct subsequences. Okay. So let's read the question first. So given two strings s and t, return the number of distinct subsequences of s which equals t. The test cases are generated so that the answer fits on a 32-bit signed integer. Okay. Okay. Whatever. Okay. Example one. So input is like triple BIT and rabbit. So it is giving output 3. As shown below, there are the three ways you can generate rabbit from yes. RABBBIT. Okay, they have played on this three B's. How three B's are getting chosen. Like first two B's are get chose, then last two, then first B and the last B. Like this, they have chosen. Then three answer is coming. Okay. And then this is BA bag. So they want like bag in this. So how they have made the bag the five. Okay, they can choose the first B here, A here, and then G can choose here or G can choose here. So it became two options for them. Then I can choose B from here and then A and G from here. So it becomes my third option. Then I can choose B from here and I can choose A and G here. So it becomes my four options, right? In options I'm missing here was two options, right? The first two options, then last. Okay, so first I guess I missed this one. This the first B and last two A and G options because I choose the first A, then I jump to the third B, third character like the second B. Okay, so let's do the next part. Okay, so we got the five. So basically, it's like a matching. So the first thought in my mind is coming like two pointer. Can we implement two pointer here? Let's see, is this possible to implement using two pointer? Because the constraints are 10 to the power 3 and English letters. Okay, 10 the time complexity is heading to taking us towards the of n square solution maybe n square solution. It is taking us to the O of n square solution basically. So how can we do it using two pointer first? Like I can maintain one R pointer here, I pointer here, J pointer here. So I will go move here, I and it matches. Okay, J matches. Then I will get the first one, right? So then I will put my I here. Then I will try to match, no match. But for the J I didn't. For the first R, what the fuck is this thing? So actually for the first R, I choose this. Let's suppose this did, and when never I can not do this partitioning things, right? Like the B or the choosing the subsequence thing is not possible. I can find like a string is present in T, so only the way I can find using two pointer. I can confirm like T is T is present in S or not. Only I can do this thing, not apart from that because how can I do like if the I got this character B and my J I and J both are okay this then J goes there J goes this okay then I goes my here and J is on I okay this doesn't matter okay I and T then it got matter then my full string I have got like then this B never get counted so this subsequence of these three B's or the combinations of these three B's is not possible like this B this never get chosen like uh, BB, then uh, BB, and then BB. So this combination, I can only do this combination as I am going only in the forward direction. So the two pointer approach is failing approach. Okay, so we have concluded that two pointer is failing. So two pointer fails. Okay. So now what I have here. Okay, two pointer fails. Okay, now what am I seeing here basically? The two pointer is failing. Then there I have to make a string b, like I have to make string t, right? I have to make string t here basically. So for the making string t using s, what are the conditions I have? Like how can I do like these things? Using s, I have to make string t, right? So I can check one thing, like I can make subsequence of, I can create all subsequence sequence of t. Okay, I can create all subsequence of s and match with the t and return its count. Return its count. Okay, I can do this. This is quite doable. Like I can do that. But what will be the time complexity? So generating all the subsequence will be take time complexity of around 2 to the power n, 2 to the power n. So it will be exponential, expo, exponential. Okay, so it is exponential. So we can't do subsequence. So subsequence is failing, is also failing. Okay. Now next, what I have, like I can see that I can use recursion. Recursion is there, but can I use recursion is there, right? But is there overlapping sub problem? Sub problem here. For making rabbit, I can choose current R. I what I see. If you see on the RA, no, triple B, right? Triple B IT at this B, or like to make this RABBIT here at point of B, I have when I my character I is at, let's suppose 0 1 2, at 2, either I can choose this B, or what I can do, I can skip this B, right? Like either I can choose this B, like I can choose this B or skip this B. If I skip this B, if I skip this B, I can still make the rabbit using last two B's. So I guess my this problem is getting solved. Like I can choose this, so I can make this B. So like this, then I can make this B also. Okay, okay. So I can see that the recursion skip and this logic is working. The skip and take logic is working. Okay, either of the in the complete recursion this is working. Okay, so let's let's write the pure recursion first, then we will, let's see how can we do that. Okay, so we will write the pure recursion. Okay, pure recursion. No, why I write it? Okay, I will write pure recursion. Okay, let's do one thing. The first way will be like pure recursion. Recursion. Okay, it will be first way will be like pure recursion. Okay, so what are the things I'm needing here? Okay, let's try to write the recursion here itself. So it is going to return uh, the distinct subsequences, right? So let's suppose int solve. So it is going to return it. So for the like I need strings, right? String ampersand s, string ampersand t. Okay. Now what things I need? Okay, I needed both two strings, right? Now I'm doing recursion, right? I'm either taking it or non-taking it. So the for the taking of current character, I can use this, and I can use this J for the T1 because I will what I will do like if R and R matches, then I will move like a two pointer approach. Like in two pointer, like we do like if the both matches, then I can move forward. Like right here, what were the two pointer? It was failing because we cannot implement this sorry, this B and this B. We are not able to find this. But in the recursion, we can do that by doing the skip and take approach, right? For the skip and take approach, we need two pointers, right? I to I for the skipping in the S and T, and J for the J pointer on the T, like on which character I am doing this. Okay, so what will be the base cases here? Okay, so first we have to always what we always do a base case first. So what is a base case here? So the one basic base case will be like if I is equal to let's suppose s dot len alien gth. Okay, so if s is len, then what I will do like I will return what should I return if I is written, but then I have to check for j also, right? Then I have to do like if I is equal to s dot len, then I should return like if j is equal to t dot le and gth. If len gth, if t is equal to t dot length, then like I am at the both are at the end point, so I can get the answer. And j will be also like t dot length, right? I have done this. Then j is t dot length. Let's if j is going to be t dot le and gth, if if j is going to be t dot length, then doesn't matter where the I pointing to, because if I have all exhausted the string t completely, means I have got the t from the s, so it doesn't matter which where the I is pointing, so I will do like return one here. Okay, and here also I'm not sure like how this working. This should be returning zero. Like see yourself. Like what we are doing, the returning j equal to t dot length, right? If the j is already t dot length, then it doesn't matter. We are making like j equal to t dot length, because if that state was already or that condition is already fulfilled in above if condition, then it will never come to down. And if it is coming to the down, it means that the we are now not at the end of string t. So what we will do, if j is equal to t dot length, I is equal to s dot length. Okay, we got the two strings here. Now we will write. I guess our base condition is, and because I and j are only moving fast. Okay, so what we will do, we will write base case is here. Then I will write logic, right? So on the logic part, what we are going to first we are going to do the skip. Okay, skip. How that skip will work. Okay, logic. The first will be the skip part, right? How can write this skip is quite easy, I guess. I will keep st here, IE plus 1 and j, because I'm not changing anything and I want to store the answer also, like the count it is coming, right? So answer will be plus, answer will be sol st and I and j, and answer and sol st I plus 1 and j. Let's see. Is it correct? Yeah, I'm skipping one, and J will. If I'm not choosing anything from this character, then doesn't matter. Checking with I or J, so I can do like if. Now for here, I want to take, right? Take. At the time of taking, I can check like I have to make this call or not. If S of I is equal to T of J or not. If it is equal, then it's my thing, like I can make the call, like yeah, it's correct, I can make the call. Okay, I can build the solution from here, right? And I can also move forward on the J side also, right? And then I can return answer, return return answer blah blah brow. Just return spelling wrong. Return. So all I am passing as t. I am passing 0 0 characters. First character 0 0 0 0 0 0. And if you still think it is also kind of what we say uh, exponential algorithm, I know that this will not pass. It should give the TLE. Yeah, it is giving TLE, and we'll use this test case for future purposes. So we pass 55 test cases. So I know that this is not going to be the pass because still we are making the exponential cost because we are some downstreaming part we are trying to we are must be doing the sub problems because it's quite simple that we can form we can see the sub problems from here like choosing one and not choosing that, then it is creating a sub problem again and again, right? So if the sub problem is there, we have only one solution to do this. We can do that but we can do one thing. ah oh yeah, we can do and memorization DP, right? We can always write an DP here. So like here only two parts are moving. So the formation of memorization, the DP here itself is quite easy. Like we can make this DP type choose this vector in type just based on the what the parts are moving here. Here int I and j. So both are the integers are moving. So we can choose this as an a moving part, so we can choose which the vector of vector string vector int and all that depends on this the parts that are moving in the recursion calls. The only I and j both two parts are moving in here. So what we will do like dp of I of j is not equal to -1, then I will return dp of I of j. I for this rabbit beat MQ, if we draw the complete recursion, this somewhere the down the string it will make it because it have to make it. Okay. Yeah, I can do this like derivative of I of j equal to answer. Let's see. Oh no, it will fail because we didn't initialize it. Int n equal to s not ngth uh, int m is equal to t. Yeah, I'm telling you, this what I'm writing t dot length and okay, I have to do the dp dot resize n plus one because outer loop is on I and then inner loop vector int m plus one comma minus one. Our usual thing this should work, I guess. Let's see. I don't think this will this work. Let's see if it passes or not. If it passes, then we will do bottom up. Oh, crazy! It passed. Okay, it passed. Okay, whatever it is. So it is passing. So currently, what I will just remove this thing like this. It doesn't make any much more sense. Okay, so what we have done here, we have used memoization. From the memoization, can we do? Can we do bottom up approach here? What we have done here currently we have implemented the top down approach, right? Top down approach, right? Currently, what the fucking spelling I have used here? Currently we have implemented top down approach here, right? Currently we have implemented top-down approach. Like from the top, yeah, I'm starting to solve recursively. So here, actually, for implementing top-down, sorry, bottom-up approach. So bottom-up still there, solve this small first. Okay, what I will do. What bottom-up basic entity is like solve small first. Okay, so from here I can see like it is getting from fronter character fronter. So we for the solving small I need big ones. Okay, solving small I need big to be solved first. So here it sets the tone of choosing choosing loop from backward, right? Right. But I have tried this, and it will give big integer overflow flow issue like this, something big, something. Okay, so doing this is not will be the great approach. I can still show you the solution. I have coded that up also. I have actually done too much on this, like runtime where I can see the code of this. Yeah, here it is. You can go down, babes. So here, like you can see the skip and that silly things. I made this long also. Like then I tried. This I will tell you. This depends on the conditions. Like for the empty strings, empty t can always be formed here, right? For the empty t, if the t is empty, means the given string t is empty, then I can make the empty string using yes, right? I can make empty string t using s because not choosing anything. I will skip everything. So I can make that. So I just put it everything like one here and like non-empty t, like if the t is non-empty and I have s as a empty, so vice versa, it will not possible. So it cannot make. If my s is empty, how can I make the t? If I have nothing to, no character to make an string, then how can I make a string? So I don't have a character. So basically that's why it's zero. Okay, so basically here I written like from the backward. I just told you like if I'm n minus one, then this thing. This is exactly similar like skip parameter like from here. You can see like I am just skipping there, so it will choosing the exact previous value here. And this is also same, like if I'm choosing, then I'm also choosing from the forward values, I plus 1 forward diagonally forward values. That's why I said like we need to solve the uh, small first, big first, then I will get the small values first. Okay, so that's why that's the implementation of this bottom top down approach, but using this. But still we can use the top down approach. The top down approach of this question is, I don't know why this failed. I don't know, this value summation is getting 64-bit integers or something. But still, we can do this using bottom-up approach. I will just copy this. I don't want to write this again. Okay. So what I will do, okay, we just remove this thing here and remove. It doesn't matter, but this is global variable and I'm on the local function. So I hope you know how this things works. No, like this. Okay, allow it. Okay, so return this remove this big shit. Okay, so I have initialized the DP, right? Now this thing is not working for the 64-bit integer I just showed you, but I can still make the similar one here. You know why? Like, you want to know why? Let's take an example of this big backpack. I don't know why I'm using this. I should use like, should I use Excalibur for a bigger craziness? Craziness here. Okay, let's do that craziness here. Let's do the Excalibur. I don't know. Okay, let's do the escalator thingy. Okay, let's choose this input for our driven or the for the intuition. Okay, so for the intuition purpose, purpose, for intuition purpose, what I will do, taking this example. Okay, let's see. So it is 2D problem. I can say it is 2D problem because there are the two parts are moving here. Okay. Should I do in the 1D 1D. Ah, I know. I don't know. I don't know. I have to see it. Okay, let's do the 2D problem. Okay. So what I want to make, I want to make back. So I will do one thing. Okay. T here A here G. Okay. See here I have empty string. B A B G B A G. I hope I'm not wrong. I don't know why these are too small. Can I increase its length somehow? What's this do? Uh, Once again, font size. Okay, I will make L here. Okay, so it is making L for everyone. Okay, also fine, good. So for can I make okay, let's go back to whatever the intuition was. We will figure out escalator somewhere later. Okay, so the thing here is I I will make string by string rather than I have made complete string and then I am trying to see like which parts are making. I'm not going backward here. I'm going forward. I will make string step by step, character by character. Okay, so we will make string character by character. Okay, okay, okay. One where I wrote the correct spelling. Okay, I can make the string character by character. Okay, so let's see if if this is s string, right? This is s. Let's see, I can write this is s and this is what is the downward arrow will be like this. And can I get downward arrow? It doesn't get downward. Whatever. It also doesn't come. Isn't it downward arrow? Okay, whatever. And uh, okay, I can use V here. Yeah. So this is T. This is string T and this is string S. So okay. So if both the strings both the string T just point on this string and this I. Okay. So let's suppose this is I, this is J, right? So for the first I'm going to traverse to all the J's. So I can trying to say like can I make the string uh, I using the characters present at the G or not? Just we will do that. Okay. So can I make empty string using empty string? Yeah, I can make that. Can I make empty string using a string B? I have to choose uh, subsequence. So I can make it. Yeah, I can make it. Can I make it using a I? Yes, I can make it S. I can make it S. Similarly, I can make it S. Similarly, I can make it S. Okay. Now for the T, can I make string T using an empty string? Yes. Can I make it? I don't have any character on the S. I cannot do escape or choose nothing. So this will be zero. Okay. So can I make string T using B? B string. It is impossible. How to make bag, right? Why have I write T here then? It should be B. I thought confused with the tag bag. Why this happening? Okay. So I cannot make the all well be will be the zero eventually. Okay. So can I make B? Yes, I can make B. So for the making B, if we remember on our recursion side, what we are still adding the answer by the skipping also because we needed that skip for this BB thing. If you remember this B, we have to skip this second B also, right? If we can skip the second B, then we can from the first and third B we can still form the rabbit. So we need a skipping logic here, right? So from the skipping also I can make the string, and also if the character is matching I can make using the skip also. If the character match I can use the skip also, and by choosing this also, if I'm choosing this, then I can just check out the previous one, like what was the value. So here I was checking for the forward, right? I can checking like, yeah, like if the forward has made, then I can make the previous one. Now I will check that if previously both characters have matched, then I can make the current one. So this will be like, I will make like it depends on the previous one. So it is depending on, so my if my current character is matching, if current character is matching, like if it is my current character is matching, my T of I is matching with S of J, right? S of J is matching, then my current DP of I of J is depends on what part it is depending, on what part it is depending. It is the sum of dp of I. uh, I'm choosing backward one. Okay, I'm choosing skip. If I skip this character, then if I'm skipping this character, jit character, then I'm falling to the the last character of that. So I minus one, because I minus one. Okay, I'm skipping this character. Oh, sorry. J is there, right? So I'm falling to J minus 1, right? Yeah, it is making sense now, because I am not choosing, I am choosing empty here. Okay, I am choosing empty here. Otherwise, I'm like, I'm choosing, uh, skipping not, I'm adding this. So I can add B here. So it will fall back to the empty string. Like, yeah, I have choose both. Then I will skip back. Let me see the what the previous value was there. Okay, so dp of I minus 1 and also j minus 1, because now the b and b, these both are eliminated basically. Previously we are adding, now we are eliminating this b and b, then it will goes to, and if I'm skipping this, then it means I'm only eliminating this b, so I will fall back to this empty string basically. So that's why this will give me 0. I have just added this 1 and 0, 0 and 1, so it will give me again 1. Okay. Oh, I should do like this. Okay. Okay. Ah, what is this? Okay. Okay. What I will do? Okay, I have a thing. Okay, b and a are not equal. So if it is not equal, then it doesn't make the sense to choose it. Can I choose any character? Like if I skip this, it will still be the previous one, right? If I'm skipping one, then I am choosing the previous one only. So it will carry forward one, right? If now both the characters are equal, then I will do one from above and one from above. Here it will be 2. So for the G, it is not matching, so it will be 2 again. So it will be 3. So it will be 3, 3. Okay, okay. This is coming. Okay, let's see. If I go wrong, then I go wrong. I don't know. So okay, J is 0. Yeah, right. Is not matching, so it will be again 0, because summation is 0. Then B is, oh sorry, B is 0, right? B is 0. Oh sorry, it will be 1. Yeah. Then for the B, A and B is not matching, so it will be again 1. So for G, it is not matching, so it will be again 1. For the B, it is not matching, it will be again 1. So for it is matching, so it will be 4. And oh, one second, I made the mistake. 3, 1 plus 4, and this is G, right? So it will get 4. Okay. Ah, G. Ah, what the shit thing is this? Okay, so I will make like, okay, so J, then yeah, again it is will be 0. And it is not matching, so previous, we are skipping this character. So if we are skipping, then this, okay, then for the A. it is matching, no, so it will carry the previous one. For the b for the b it is not matching, so it will carry the previous one. For the g it is matching, so it will carry one. The skip plus take took wala part, took part. Then G and B is not matching. Then again it will be one. It will carry forward. G it is not matching, so it will be one. And for the final G it is matching, so 4 plus 1 it will be 5. So does this give us answer of equal to dp of what give me answer baby. And it is giving us the answer. Dp of m of answer will be this count, right? So basically this is the solution, or this is the string. Okay, can I copy this? I can copy this. I can paste it here, right, for the better understanding of ourselves. Just little bit, yeah. It okay, okay, whatever this thing is there. Okay, so basically we have to make this. I guess we have to change this iterations also. N plus one to n plus one. Ow. Okay. Okay. N was s dot len. Okay. Okay. Let's do the traversal then. Uh, 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 should we do this first? I don't know why this are these got too much. I can see here properly. That should we do this empty string and this first? It will be better. Then I can just go on this only filling these and these from. I can just start filling from here itself, because our actual answer start from there. Okay, so just let's pre-fill. Just fill for obvious things, obvious calls, obvious states. Okay, so the first one will be, if I make everything zero, I'm making everything zero, right? Okay, I will just do that in the first row only. I doesn't need to go for the first column. I will make only first row. Okay, so what will be the first row? Int I. So row is traveling from for the end, right? So it is traveling from int I is equal to 0. I is less than n I plus plus. Okay, so for I'm doing this for 1. So what which state is remaining? My row number is 0 and my columns are getting changed, right? So it will be I, right? And it should be equal to n, right? Because n plus 1 and that thing, so it should become 1, right? Because we have input, so our starting will be like complete 2D array with the zeros, so we didn't have to make this second one. So I can the fill obvious sets for first row. First row we have done here. Okay, now the column thing is going here, right? Now the column things we didn't need it, right? Now then just do the our actual thing. Let's int equal to 1. The first, this will be like 0 1 0 1, so this will be the 1 character. So I will start from 1. I should be less than or equal to n I plus plus. And for int of j, from where the j should start, I was filling, but I have just, okay, I'm also starting from 1. So j is less than or equal to m and j plus plus. Am I doing correct or wrong? I'm doing wrong here, because this is the row, right? This is column. Yeah, I should swap it here only, then it is the quite easy thing, you know. I done j. I got j. Then let's do one thing. I'm going to fill dp of I of j, right? Either of the way dp of I of j will be equal to j minus 1. Okay, and I want to check if s of I minus 1, obvious, but I'm checking. This is for the character t, right? S of I, it is going toward the m, and it's equal to s of j minus 1. I'm doing j minus 1 because this is zeroth base. String is on zeroth base, and we have choose the one based index in here, so that's why I'm doing the. Then I'm adding the dp of I of j is, is getting added with dp of its previous states. So the previous state was this previous completely chosen state was this dp of I and I2. Return dp of first will be m, second will be n. Second will be n. Oh, yeah, I have this. This is in the format code thing. I want to see what it formats. Yeah, it doesn't format. It just formatted code. Okay. Okay, just add this. Let's see if it works or not. Yeah, I just have where the thing, but I have never called this all thing. Let's suppose let's do this. I guess yeah, I got it. Vector and long long. I have missed. Yeah, I will do this again. Vector of vector and dp of m plus 1 vector of and n plus 1 comma 0. Uh, uh, yeah, it is working. I just remove this code. This redundant code with no, I can use this as an explanation. Okay. No, 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 no. I hope this should work. Well, it was quite 50-50 case. It got failed. What? This is also giving me the test around. What? Leaves. This condition is failing. Yeah. Again and again. It goes to the 63 and then again it also get failed. Doesn't matter what I do here long, long, or here long, long. I can use this test case here. Check if it passes this test case. The accessor is passed. Then again, I guess it will fix that 66 number. 3, I don't know why this is failing. But more or the less, I don't know which, how to handle this. I wish I'd use unsigned int or something. I don't know how to use that. Whatever this set is saying, this never makes the sense. Not give it is not giving TL, it is runtime error. No, so this is not the question. But whatever things. So basically the logic is same. But that code got passed, but this is failing. Quite strange up here. They said it will be on the 32-bit integers, right? I guess the logic is clear, I guess. We can do on the memorization, it is passing, but I don't know why it is failing now. But it is what it is. Now I have to check. If I found the solution, I will add the clip or I think the logic is more important rather than this. And this is quite easy. This should not be mac hard. It should be medium most probably. And it's quite what I can say, like it's quite not intuitive, but it's quite classical problem. Okay, so the small solve for small first it got so how we approach this solution. Let's do the recap. First, we done the two pointer approach. We tried with the two pointer and it failed because we didn't get the BBBVIT test cases. Okay, so we scratched up that two pointer. Then we get back to the recursive solution from the two pointers Intuition, like we can place the two I and J here and then we can do that. So we done that, and from that, the if we got the TLE, then we use the memoization, and that memoization got passed. Okay, so we got one valid solution using memoization, and we got the memoization on the two variables I and J here, like this here. That we had to the skip logic things, and that this we done, and then we used too much brain and we tried to do the top down approach, but it failed miserably. I don't know why. But it should pass. I think I don't know how to fix this, but we will see. So basically, this is the question answer, and if you like the question, then solve more. Okay, bye bye. Take care.